great to see everybody here after 2 years of lockdown and COVID. And it's nice to be able to get to see old friends and colleagues again.
Doesn't it?
If we all jump to the lifeboats, is that okay?
So, firstly,
we are working now.
That's another sort of energy sustainable technology that sort of is great but works against us. It also burns the grass in my yard.
Okay, good morning everybody, and I'd like to introduce my talk, which is about the relationship between building design and fire spread, looking at how the geometry of buildings in the form of overall shape, geometric form and architectural features can influence the behaviour of fire. How do I change this? Spacebar, okay, thank you. Right. You can see a bit about myself there. You can see that I'm multidisciplinary and I belong to quite a few professional institutions. As a job, I'm the fire engineer for Intelliclad, which some of you may have heard of, and I'm also sort of an independent consultant in my own right as well with Olympus Fire Safety, which again some of you may have heard of. This is basically the objectives of the work I did. It was inspired by Grenfell, and when I first saw the building, footage of the building burning, it seemed to me that the geometry of the building was having an influence on the spread and behaviour of the fire. So I decided to look at this further. I mean, I believed it would make a useful contribution to the investigation. So I produced some reports on it, which I submitted to the Grenfell inquiry. But it also had other benefits as well, because it would enable an understanding of how fire behaves and spreads on buildings. It would make it easier for people to recognise the risks. And from this research, I've established a set of principles for which it is now possible to predict the spread and behaviour of fire if a fire occurs on a building that has a combustible façade. And then, of course, it can also have benefits for building design, firefighting, testing, and a few other things which I'll look at in a bit more detail in a minute. It's also revised to a safety assessment, it's similar to a risk assessment, but a bit more detailed, because it takes into account the geometry of the building with the architectural features and assesses those along with all the other things, like the materials, the fire protection, and so on. Right, so those are the 5 main applications of my work. You can see fire investigation, architectural design, firefighting, facade testing, and then remediation and mitigation of fire risk and unsafe buildings. And the work is actually seeing real-life applications in some of these areas. Like the first one, fire investigation, has been used to help explain the spread of fire in some buildings which have had fires recently, such as the one in Milan in August last year. This research was actually proved very valuable in helping to explain how and why that fire spread as it did. And of course, the geometry of the building had a significant effect upon that fire. Obviously, with architectural design, if certain features or shapes of building are considered known to promote fire spread, then perhaps that should be thought about at the design stage before the building even leaves the drawing board. Obviously, with firefighting, if the firefighters can be aware of how the fire spreads and they know perhaps what it's going to do, it will help them make decisions regarding evacuation. Façade testing is another one. At the moment, you've just got like the main wall with the wing wall at 90 degrees to it, but that's not representative of a lot of buildings. A lot of buildings have geometry which is much more complex than that, and you may get that some types of construction, some materials may perform all right and pass the test with the simple geometry, but if they're applied to something rather more complex, they may behave very differently. And then finally, the remediation and the mitigation risk of unsafe buildings. This can be taken into account with some mitigation measures, like for example, Intelliclad, which is a facade-based fire alarm and detection system. This research is used when making decisions as to where to position the sensors. Obviously, it can identify the parts of the building which pose the greatest risk, and the sensors can be positioned so that they cover those areas. Now, I've looked at quite a lot of case studies. These are some of the main ones, although if you get the report, there are quite a few more than this. And, of course, as I produced the report back in 2019, and nearly another 3 years has passed since then, and I've continued to look at fires in relation to this work. And, of course, as you'll know, there have been several serious fires in the years since. So anyway, we have what are called the three basic layers of building geometry there. You've got the overall shape, so you can see there's outlines of 3 different buildings which have suffered fires. So like you've got the Olympus Tower and Grenfell are basically square, and this Taksim Yardian Hospital in Turkey, which had a fire back in 2018. You can see that's basically a triangle with a semicircle attached to it. Then if you look at the geometric form, that refers to like the larger features. So on the middle one, for example, you've got like protruding curved sections on each face of the building. Things like architectural features, for example, would be things like string courses and pilasters. And each of these can affect the behaviour of the fire, and each has some unique fire behaviour associated with it. And of course, if you're building with complex geometry, you can get several different phenomena sort of influenced by the geometry occurring at the same time. And this is just like basic list of the different types you can get. Obviously, the fire can spread upwards, so as like the directions on the left and the places where the fire could occur, and that's basically the type of phenomenon you can get. It can spread, vertically upwards with an inclined front, or it can concentrate itself on a feature on the building face and spread upwards that way. And you've got some similar with downward fire spread, although, of course, in that case, it will be, melting and dripping of certain materials, things like, you've got ACM panels of the PE core that will sometimes that will flow down some of the features, taking the fire with it. And of course, horizontal fire spread, usually very slow, but if a feature is involved, it will make that much more intense and a lot more rapid, and it can also help to take the fire to other parts of the building that it otherwise wouldn't be able to get to. And things like edges, corners, they can influence the fire, because the fire will tend to concentrate itself on those and behave in particular ways. Now the other one, the trench influence, that's basically like what happened at King's Cross, the escalator fire in November 1987, where they had the sides of the escalator and the steps, and that formed a trench. And you had, what is known as the trench effect was discovered, where the hot gases and the flames became trapped in the trench, causing the fire to be more intense. Well, since I've done this research, I've discovered that the same effects can be applied to buildings. They can occur on buildings if they have a deep recess or two parts of a building that are close enough together to form a recess. And then, of course, other things like the surface area on particular features. I mean, like with the crown at Grenfell, because it had slats in it, that made a difference there. And whether the flames are constrained by a feature, confined to a corner, or whether they're exposed will again affect how they behave. Now, looking at some of these in a bit more detail now, we've got upward fire spread, and I've come up with a definition of each type, as you can see there. And the top one, you would think that would occur quite frequently on a building, but actually that is actually rather a bit more unusual, because most of the fires I've looked at, there's actually been something that's been guided the flames upwards, either been on a thin section of cladding which has confined the flames and directed them upwards, or they've been on a feature, or they've been in a corner. So, because if you get fire on a featureless building face, it will tend to sort of meander about and not spread upwards vertically in the same way. And then you've got obviously feature influenced, where if you've got some feature on the building face, the fire will concentrate itself on that, spread upwards without spreading horizontally. And the same with corners, the trench effect, which I've just mentioned. And then the bottom one's an interesting one, which is upward fire spread with an inclined front. If the building face is curved, that will lead to a distortion of the fire front, and you tend to get the top of the fire front moving faster than the bottom, and this causes the fire will have a tendency to follow the curve, and then it causes the fronts to become inclined, and I'll show some examples of that later. Here are some examples. So you've got the upward vertical fire spread, as you can see there. That's the CBuildE Tower in Dubai. It's sort of on that band of cladding, but there's also that vertical row of balconies there. And the vertical row of balconies will behave like a solid wall. The fire will get into the corner, and it will spread upwards. I mean, it tends to go upwards without much spread horizontally. But if it is well enough developed and catches one of those features on the balconies, they will spread that way, but it tends to mainly just concentrate on going upwards. The one in the other two images is that's in Turkey, that building is, the Chartered Tower, and as you can see there, it's got a section of uninterrupted cladding between two areas of glazing, and the fire's just spread directly upwards on that section. And there's some more examples here. You've got the Olympus Tower in Grozny, which is in Chechnya, which is part of Russia. And again, it's spreading upwards on a narrow band of cladding there, but there is a very small inside corner there, because there's a curved section in the middle of that building face, as you would have seen on the slide earlier on. The other building in the middle, that's in Dubai. It doesn't seem to have a name, but it's in King Faisal Street in Dubai. And that's got a fire, again spreading up a tall band of cladding, but there is again a small section of protruding building face which forms an introverted corner, and again it's concentrated in the corner. And then our last one is that's in France, and again you've got a row of balconies there, behaving as if they're a solid wall, and you've got the fire spreading upwards in the corner there. And again, it's feature influenced. This one on the left is in Las Vegas in the USA, and there's some pilasters, as you can see to the left and right of the fire. There's pilasters there, which protrude slightly from the wall, and the fire has concentrated itself on those pilasters and is spreading upwards. Grenfell is in the middle with fire concentrated on the columns. Then you've got the Olympus in Grozny, the right there with again the fire concentrated on the it's on the curved section there, and you can see that it's got a diagonal the fire front has become inclined as it crosses that curved section of building face.
Tall Building Fire Safety Network delivers high-quality safety management training for anyone involved in the fire risk management of high-rise or tall buildings. Recognised by the Institution of Fire Engineers, we've been delivering fire safety training since 2011, and many organisations rely on our training for gaining competence in this field. Sign up for our training courses and conferences in 2023.
So, right, and the trench effect. Now here is some examples of where that has occurred. This one is Knowsley Court in Liverpool, which occurred back in 1991. And you can see that there's like a wall on each side of that, and you've got the trench there. The fire's gone into that, and it's just gone straight up inside that trench. The middle one's in China, and again, it's the fire's in that recess there, going straight up. It's throwing flames out the top, because the escalator at King's Cross was acting like a flamethrower, throwing flames out across the booking hall, which unfortunately killed 31 people, and that's having the same effect there. And of course, with the trench effect, the angle is very critical. And with the bottom of the trench being at 90 degrees to the horizontal, the effect is going to be very pronounced in any building on which it occurs. And then the one on the right is the hospital in Turkey, which I had an outline of on the earlier slide with a triangle and a semicircle. And because where those are joined by a shorter section of building, that actually forms a trench. So the two parts of the building, the way they connect, forms a trench, and you've got the fire concentrated in that. And there you can see there the trench sides are labelled. The floor of the trench is labelled on there, as you can see on between the two main parts of the building. And looking at curves, as you know, curves can be vertically orientated, horizontally orientated. That one's horizontally orientated. The Olympus Tower was vertically orientated. They can be convex or concave, pronounced or slight and gently sweeping. And of course, they can all affect the behaviour of fire. So, and these are basically the principles associated with curves. The more pronounced the curve is, the greater the angle of distortion with the flames will be. And the extent of the lateral spread in relation to the upward spread, because you can only get an inclined front if you've got the fire spreading upwards and horizontally at the same time. If it just spreads in one direction, you don't get it. And so it's the extent of them, the proportion of them in relation to each other, which again determines the angle of deflection. And so, moving on to downward fire spread. Again, those are the definitions of each type. And as you can see, it involves continuous bands of cladding, which the fire will flow down. If you've got molten material flowing down, taking the fire with it. You've got downward fire spread in an inclined front. That was seen at Grenfell. Fire spread along the crown. The polyethylene in the cores of the ACM panels melted, it flowed down the building, but and every time because I'll explain this later, but because the fire was spreading further along the crown than it was lower down, you had the inclined front there, and you had horizontal spread at the top, whereas at the bottom the fire was trying to go vertically. And again, there's some examples there. Now, those two, the photo on the left and the one in the middle, you would, anyone would be forgiven for thinking that those were Grenfell Tower, but they're not. They're actually the Olympus Tower in Grozny, and that had the same phenomenon as Grenfell. The fire affected all four faces of the building Fortunately, nobody died because they all evacuated from that building quite promptly. But again, it had like a projecting rim around the top of the building, and the fire caught that, and that enabled it to spread to all four sides of the building, as well as some string courses which were lower down. Again, the fire latched onto those and was able to spread to all the four faces of the building. And then you've got that one's in Dubai on the left, and you've got and there it is after it was extinguished. As you can see, there's substantial downward fire spread there as the molten material has run down the building, focused on those uninterrupted sections of cladding and taken the fire with it. And then the one on the right is again, that's the Olympus in Grozny, which where the fire affected all four sides. And horizontal fire spread, again, with the definitions of the various types there. As you can see, the standard horizontal fire spread is usually not very fast, but if it's got a feature there, that will encourage fire spread, as will any feature around the roof. And from that point of view, horizontal fire spread can actually be worse than vertical fire spread, because it has the tendency to take fire to other faces of the building, which you wouldn't otherwise get to. Rotational fire spread is the action of a fire actually going around the corner of a building. Where a section of cladding burns, you tend to get a clean line, because it tends to just go straight up and not go around the corner, so you have like a clean line on the corner between the burned cladding and the unburned cladding. But if there's a feature present and the fire latches onto that feature, that will enable it to go around the corner. And I have some examples of this. As you can see there, the one in the middle, you can see that's again the Olympus Tower. All three of them are the same building. And you can see that that building face has been extensively burned. That's the corner. And you can see like a straight line there. But the fire hasn't gone round that corner at all. It's just spread straight upwards. But as you can see, those two black lines on the left, horizontal black lines, they're string courses, and the fire has latched onto those, and it's gone round the corner. And the one on the right shows rotational action of it going round the corner. So you can see, the one on the left is just ordinary standard horizontal fire spread, and you can see it's very slow, the flaming is very weak. And if you watch a video of that, you'll see at one point it almost burns itself out. And then the fire catches some features on the building, and suddenly it just flares up again. And it burned for many hours. Rooftop fire spread. This is in Grenfell Tower. I think it's changed its name now, but this is in Dubai, and it had a fire in 2012. And again, that's got a crown on the top. And the fire went up one side of the building, caught the crown, spread horizontally through the crown, and then down the other side. So that was another example of how horizontal features on a building can cause the fire to transfer itself to other sides of the building you wouldn't necessarily affect otherwise. Of course, with it being having openings in the structure, it had a large surface area, it had a draw of air through it, which of course intensified the fire. There's an exposed location with plenty of oxygen, and that's the corners there. So basically, that's fire, as I said before, won't necessarily spread around the corner unless another factor is present. It would have wind or architectural features. Inside corner, as I said before, will concentrate itself on the inside. Now there's a limited amount of oxygen on the inside, so an inside corner, so that the flames tend to extend upwards as they search for a better supply of oxygen, and in doing so, they heat the fuel ahead of the burning zone, and that enables the fire to spread quickly. And there you can see what I was saying about the angles of various corners, and you've got some examples there. Again, that's the building in Chechnya. And here with explosion and constraint, as mentioned earlier, the flames will spread randomly in multiple directions unless there's something to constrain them. This is why often you get fires that sometimes will spread 2 ways around the building. There's nothing to direct the flames upwards. You saw this happen at Grenfell. The fire went up the east face of the building and then it went in 2 directions. That's when it reached the crown. And because the crown was a horizontally orientated feature, there was nothing to continue to guide the flames upwards, so it spread horizontally both ways and then started to affect other faces of the building. And as mentioned there, it's more of an issue towards the top of a building because you're likely to have more horizontal features up there. And here are some examples. That building on the left there is in Dubai. And again, you've got the windows there. We've basically got some extensive expanses of cladding there. And you can see the fire has moved around fairly randomly on that. This one at the bottom is a building in Shanghai in China, which had a bad fire back in 2010. It killed 58 people. So that's the second biggest death toll in the Façade fire after Grenfell. And it's got scaffolding on the outside, and you tend to get some of this phenomenon occurring on scaffolding as well. And again, because scaffolding consists of sort of horizontally orientated wooden boards, there's nothing to direct the flames straight upwards, so the fire tends to move about, and then you get diagonal fronts with spreading in multiple directions. And again, you've got the same thing with the one in Las Vegas at the top there. The fire's gone up that building, guided by features, and spread 2 ways. Because that had a cornice at the top and several string courses, which would encourage the fire to spread horizontally. And there's Grenfell looking in detail at the crown. So you see with the one on the top left-hand corner there, the crown has a large surface area, which encouraged burning. You had the old crown in front of the new crown in front of the old crown, and there was a draw of air between the two. And as I said, it was horizontally orientated. Of course, you had a small amount of vertical spread up each of the individual slats. And you can see in the middle how the fire's being drawn between those 2 crowns, and it was almost like a sort of mini chimney effect between them, because you can see the portholes of the older crown there. And then after the fire's being put out in the bottom right there, you can see that the new crown has pretty well been destroyed. There's not much of it left, and you've got the old one visible behind it. And coming on to the safety assessment, I won't say too much about this because I'm conscious of the time. I've only got a few minutes left, but it's like the only assessment which takes external geometry into consideration. It's both a quantitative and a qualitative assessment, and it comes up with a numerical factor which I've got a scale of figures which ranging from low risk to high risk, and it comes up with a numerical factor which can be compared to this scale, and it will tell you exactly how safe or unsafe a building is, which of course is a useful thing to know. And finally, as I was saying about Intelliclad at the beginning, as an example of one building there where I showed where some sensors could be positioned. You've got a deep trench there, and so the sensors are being put on what would be the trench floor. Yes, it can replace a waking watch system, or it can be part of a mitigation strategy, so there's many things which can be done with it. And of course the sensors will detect any fire which affects the cladding within minutes, because it was tested by the FPA. In as little as 6 minutes, the sensors have picked up the presence of a fire which had started outside the test rig in a wheelie bin. And it would pick up fire before it's even had a chance to be visible from the outside. So it is a very effective system. And research has shown that 60% of fires that have occurred in facades since 2010 have started externally. So they'll start on balconies, people will leave rubbish outside buildings, perhaps a car might catch fire. There's all sorts of things that will cause a fire to start outside a building. And then finally, that's the conclusion. Obviously continuing work, and I've written several more reports since. My research is now starting to see some real life application, and I've got a useful set of principles which can be applied in various different areas. And then these are some of my other reports which some of you may have seen. I have of course since written a report about the fire which occurred at Whitechapel back on the 7th of March this year. That was a building with a glazed curtain wall system. But of course put this presentation together before I'd written that, and I think before that fire had even happened. So anyway, well, thank you for listening then.